All right. So on the exam, anything in particular you want to see? I'd like to do number 2, maybe what you think about it. 2A, there was a minor difficulty on this. If g of x is square root of x minus 4, what is the domain? What is the range, right? The domain is supposed to be all possible x you can put in, and the range is all y that might come out, right? So this is y equals g of x equals square x minus 4. What's the domain? The natural domain of an algebraic expression is everywhere except where it causes a division by 0 or an even root of a negative, right? So when you look, oh, there's no divisions, we don't have to worry about that. But there is a second root, an even root of this. So the domain is simply x minus 4, not negative, right? But you always want to simplify that. That's part credit, right? You just add 4 to each side and say the domain is x greater than or equal to 4. Also known as, if you like the interval notation, 4 to infinity. You always want to use a round bracket with infinity because infinity is not a real number, so you don't want to include it. But you put a square bracket here and indicate you do include the left endpoint since we don't have a strict inequality there, right? X greater than or equal to 4. But square bracket includes 4. Now, what's the range? This one, it really helps to make the graph. I like it on these doing your graph, but you don't have to. You can simply say this. I can make this any non-negative number I want by picking x bigger than or equal to 4, right? I didn't put this on the key, so I just, because it's too much writing. I make this any non-negative number I want. So I make it 0 is the smallest I can make it by taking square root of 0. But if I want to get square root of 100, I just make this. If I want to get 10 for this, I just put 100 in here. If I want to get a million in here, I put a million squared under the square root. So I make this any positive number I want. I simply make the range y greater than or equal to 0. I make 0 by putting in 0. I make any bigger number by putting it square under the square root. So the range is y greater or equal to 0. Or you can sketch it. You can say, here's the y equals square root of x function, right? What does y equals square root of x minus 4 look like? Remember? This is y equals square root of x that we memorize as a half parabola, right? If you square this, it's x equals y squared, except now this is the whole parabola, right? So this is the half parabola. It's like the y equals x squared, except around this axis and half of it. Because right, the square root means the non-negative number. If you figure that y values that come out are as small as 0 and go up forever, so you can figure it from the graph also by, I should say, moving this over. Y equals square root of x minus 4 is just a shift, a translation over 4 units, so it's the same shape, but right over here. Once you figure, oh, but this is just a translation of this one, then you say, aha, it goes up forever. Its range is all non-negative y. So you can do it by the graph, or you can just do it by arguing to get any non-negative number. I can put a square in here and it'll work, right? So this is what I wanted, or I could put the interval notation and put 0 to infinity. Any questions on 2A? Some people missed that one, and I want to make sure we have that concept down because it comes up in the beginning of calculus if you go on and take that. A lot of people take trig right after this class and then calculus. All right, so 2B. And domain and range come up a little bit trigonometry also. So find a formula for G inverse. Make sure we have this concept now because it does come up. If you have y equals g of x, to find the inverse, you write x equals g of y. You just interchange x and y in the equation. So you solve this for y, and that'll give you the inverse. So solve x equals g of y for y to get the inverse function. So how do I solve that? I can square it. X squared equals y minus 4. Add 4 to each side. I've got y equals x squared plus 4. Here's what I asked for in the answer, but technically this isn't quite right. I may have marked your paper. So I gave you full credit for this. Why isn't this right? I should have put this picture back here. Here was the picture of y equals square root x minus 4, y equals g of x, right? With a half parabola starting at 4 here. This one I'm claiming is the inverse is supposed to be the flip of this one over the line y equals x, right? Remember how to get an inverse? If you have y equals g of x, the inverse is x equals g of y, which this is. And it's equivalent to flipping over the line y equals x. If this is g of x, its inverse ought to start at 4 and be the same shape going up this way. This ought to be x equals g of y, also known as y equals g inverse of x, since it's a function. Here's the inverse relation, but this is a whole parabola, right? So what's wrong? What's wrong is when I squared both sides here, I introduced some new solutions. This is not equivalent to this. It implies this. If x equals this, then its square is equal to this. But to be equivalent, this one, since this radical sign means the non-negative number that has a square, we need to put x, it has to be greater than or equal to 0, right? So this, by squaring both sides, we introduced negative solutions as well as positive solutions. Now x could be minus the square root of y minus 4 as a solution to this one. So to be equivalent, we square both sides and we restrict x to be greater than or equal to 0. Now we get this. This is what we want. So on part C, I said, state the domain and range of G inverse. You can get it from here, but it's easier just to say, when you take the inverse of any function, the domain of the original function becomes the range of the inverse. So if this one has domain 4 to infinity, then its inverse has range 4 to infinity. If this one has domain range 0 to infinity, then this one has domain. They interchange the domain and range since you're interchanging x and y coordinates. This is y equals g of x, this is x equals g of y. So this one has domain 0 to infinity and range 4 to infinity, interchange the order. And now this is the graph of y equals g inverse of x as a half parabola, just like this one was. If you plot y equals x squared plus 4 together with the restriction that x has to be greater than 0, then you get a half parabola. Okay? This is PD. Sketch both. So tricky, huh? Of course, that's what comes up in the test. Y equals g of x. I want to be a little tricky to make sure you understand the nuances that are going on here, but I don't want to be so tricky at docking a lot of points. So I tried to do that in this problem. Make sure you understand the concepts, all of them, without being too harsh on the mistakes. So there's their plots. G of x and g inverse of x. It's flip over the line y equals x. This is very important in inverse functions in calculus because they do inverse trig functions and so forth. And it's really useful to have that concept. Any questions on 2? What others would you like to see off the test? Anything? Some of these you did so well, I hate to just repeat them, but others we had more troubles on. Like,
can you do 15?
Yeah. So here's 15. Actually, this is one of the ones I really wanted to do too. A lot of people miss this. Solve by a substitution. This was on the homework, just like this, maybe a slightly different equation. But this kind of thing comes up on your ACT and so forth. This will raise your score, hopefully. They like to do this one. Y to the 4th minus 9y squared equals minus 14. How can I solve that? We didn't do 4th degree equations, right? But because it has only even powers, I'm going to make this substitution. One of the troubles is we don't have enough time to do every homework problem in class, and nobody ever asked me this one. I didn't ever get to this one, so I don't think we quite did this one, even though it was on the homework. I want to make sure you could do it, and I put it on the practice exam, I think. You substitute u equals y squared to get, well, if u is y squared, then its square is y squared. Squared is u to the y is y to the 2 times 2 is y to the 4th, right? So this becomes u squared minus 9u equals minus 4 quadratic equation. Now it's only second degree. But to solve the quadratic equation, what's the first thing I want to do? Yeah, move the 14 over so I get 0 on one side. Whether I factor or use the quadratic formula, I need 0 on one side. There you go. And now I can solve it either way. I can factor or apply the quadratic formula in this case. Both will work. I think since this one factors, let's use factoring. Or did I say use the quadratic formula? Did I say? Okay, then you can use either. I notice on this one that if I try factoring, since it's just u squared, I have u plus blank, right? The coefficients of u are 1, so the product is 1 here. I just have to figure out what goes in the blanks. And we recall, so it has to be 1u and 1u to get the leading coefficient 1. Remember, the product of these has to be 14. The product of these has to be 1, so I put 1s. Product of these has to be 14, so I can put like 14 and 1, or minus 14 and minus 1, or 7 and 2, or minus 7 and minus 2, and that's it. The ones I can guess. If it's not those, then I have to use the quadratic formulas because it's got nasty square roots that are hard to guess. It always does factor, but sometimes it's got nasty square roots or even imaginary numbers. I want to give you a hint now because, again, one of the big purposes on this is to do the advanced stuff now, make sure you understand the details. So watch this. In the special case that you have lead coefficient of 1, I know more than the fact that the product is 14. What else do I know about these two blanks? What's the sum of those numbers? We didn't do this before, and you don't need it to do this problem, but I want to, only when the lead coefficient is 1, the sum of them is equal to this number. Since the coefficient, the number that multiplies, u squared is 1, in that case, not only will their product be this number, but their sum will be this number minus 9. You can figure it out if you FOIL it. You just FOIL it and prove it that way. Once you see it by FOILing, you've got the proof. And just try to memorize it. So what two numbers multiply to 14 and sum to minus 9? Now there's only one choice, minus 7 and minus 2. Right? Product is 14 and their sum is minus 9. And then I'll have to try all the others. So you don't have to do that. Just try all the numbers in here whose product is 14. That's what I expect on the test. Try minus 14 and minus 1, and plus 14 and plus 1 will give you positive in the middle. You know how to try that. Try minus 7 and minus 2. And all that works, right? You just FOIL it out and check, right? This time this is u squared. And minus 7u minus 2u is minus 9. Minus 2 times minus 7 is plus 14. Check. So you check by FOIL. You try all the numbers. But if this is faster, when the lead coefficient is 1, you can do that. Give you the advanced stuff today. And then you'll be experts in take your next math class. So let's write it out in abbreviated form. U minus 2 times u minus 7 equals 0. Right? There's written a little cleaner. This is equals 0. And now, what are the solutions to this? Obvious, right? By the zero product property, you have this number times this number equals 0. Either this number equals 0 or this number equals 0. You don't have to write this step. As far as I'm concerned, once you're used to this, you say, oh, u equals 2 or u equals 7. I just wanted to put the zero product property in why this works. Right? I always remember math better than taking Spanish or something because I knew why it was, not just what it was. You know, in Spanish, you memorize the word, you memorize it. What was that word? But here, if I forget, you know, I can figure it out, right? In 2 steps, what I couldn't memorize in 1 step. So one of the things I like about math, I took Spanish too. It's hard learning Spanish just like math. All right, so u equals 7 and u equals 2, but that's not the solution because u was my substitution I made put in there. So this is actually y squared equals 2 or y squared equals 7. Well, if y squared equals 2, we deduce that y equals plus or minus square root 2 by square rooting both sides, or y equals plus or minus square root 7. Those are the two numbers whose square is 2, and two numbers whose square is 7. And just to be real detailed on this and make sure everything's real clear, that's on. The formal way, what you want to do is memorize this. When the square is a number, a positive number, then there are two solutions, y equals plus or minus the square root. Why is that? It's because you do it like this. You write it y squared minus 2 equals 0, and you factor this as y plus square root 2 times y minus square root 2, right? It factors like that. And now you say, aha, y is negative square root 2, so that this factor is 0. Or y is plus square root 2, so that this factor is 0. Factoring proves that these are the two solutions. But after a while, you didn't. So I'll point that out also. There's what I wanted to see for the answer. Plus or minus square root 2, plus or minus square root 7. 4 solutions to a 4th degree polynomial equation. Any more questions on that one? That was a good problem. All right. Let's use the solve quadratic equation by factoring and see some cleverness. Whenever you get all even powers, you can reduce it by substitution. Right? But that's why that was on the homework. These do come up actually in some of these standardized tests and so forth. What else would you like to see? I'd like to do the last two. Then we've just been doing quadratic equations. Let's try this one. 16a, suppose I take 2x squared minus 2x equals 5. Solve this exactly. All right. You have calculators that have a solve function on it, and it will solve these equations for you. If you have the real fancy calculators, they'll solve them exactly. So when you do these, go ahead and check your answers. But I do want you to be able to solve these by hand also. This is very important. Sometimes you'll get later ones where there's more variables and you have to solve it in terms of the variables in the calculator. It just won't work. So you have to learn the technique here too. And that's why on some of these problems it slow work. Right? Although I think I neglected to do that on here. I should have. Again, when it's a quadratic equation, ax squared plus bx plus c, put it in what we call standard form. 2x squared minus 2x minus 5 equals 0. Get 0 on the right-hand side. We call that standard form for a quadratic equation. And the reason is that we call this the standard form for a quadratic polynomial, a second degree polynomial, ax squared plus bx plus c. Remember, quadratic polynomial means its highest power is second at second degree. So there's standard form for the polynomial. When we put a polynomial standard form equals 0, we'll call it a standard form for a quadratic equation. Once it's in that form, we can try factoring in some cases, but I said here, use the quadratic formula with good reason. If you try filling in the blanks here like you did in the last one, it's very hard to guess what goes in the blanks. It's not so easy. When it turns out to be integers, numbers with nothing after the decimal point that go in the blanks, you can guess them like in the last one. But this problem, no such luck. We're going to go to the quadratic formula. I recommended it with good reason. Quadratic formula says if I call this ax squared plus bx plus c, including the sign here, right? So b is minus 2 and c is minus 5. Then the solutions immediately by formula are minus b plus or minus square root b squared minus 4ac. If you didn't quite remember this one, right, it's your detriment, right? Because this is a very important formula, one of the more important formulas of the whole course. Maybe the most, I don't know. Depends on what you do afterwards. Minus b is minus 2, so minus b is plus 2. Some people put minus 2 here, too many minuses. Plus or minus square root, minus 2 squared minus 4 times a is 2, and c is minus 5. Some people forgot the minus on that one. And all over 2a, 2 times 2. So these are the solutions immediately. You just write the formula down. That's what's beautiful about the quadratic formula. It always works on any quadratic equation, ax squared plus bx plus c equals 0. Even if you have solutions with imaginary parts, right? I equals square root minus 1. All right, so this is 2 plus or minus, let's see, 4 plus 40 is 44 all over 4. And that is truly the two answers, but what do you want to do with that? Most of you got it. You want to reduce it, right? I can't, and some people divided 2 by 4 and got a half and didn't divide these the same. You want to factor and cancel, right? I'm going to write the 44 is square root of 4 times 11. So it's square root of 4 times square root of 11. I'm writing the detail. Is 2 square root of 11. So this can be written as 2 square root of 11, and I can rewrite it as 2 times 1 plus or minus square root of 11. All over, I'll write 4 is 2 times 2, right? So I factor 2 out of every term in the top. Terms are things that are added together. And I factor 2 out of the bottom. And now I can cancel the factor, something that multiplies the whole top, with the factor of the bottom, something that multiplies the whole bottom. So factors are things that multiply together. Terms are things that are added. I cancel the factor of the top and the factor of the bottom, and I get 1 plus square root of 11 over 2 is one solution. 1 minus square root of 11 over 2 is the other. I wanted you to simplify it like that. Good. Now, 16b is also useful. But what this tells you, again, I'm doing the advanced stuff today now that you're experts on this. I want you to understand. What does that mean, this original polynomial on the left here in standard form? 2x squared minus 2x minus 5 would look like if I factored it. Whenever I solve quadratic polynomial equals 0 and get the solutions, the factoring would be is the lead coefficient 2, this number, times x minus the first solution of the quadratic equation times x minus the second solution. In other words, what goes in here if I tried to factor it would be 1 plus square root 11 over 2 and 1 minus square root 11 over 2. Who would ever guess to put those in the blanks? That's why you don't want to factor this one, right? So this is how it would have factored if I wanted to factor it. But this is a very important property of these things. When you solve polynomial equals 0, it tells you exactly how it factors. And factoring is extremely important in higher algebra classes if you go take higher algebra. So that's just a side note. I didn't ask you to do this because I thought it was too hard. But in the long run, if you remember this, it's really useful later on. All right. Now, 16b. Suppose I solve x squared plus 2x plus 5 equals 0. It's already in standard form. Again, use the quadratic formula. Once again, it's because it's hard to guess what goes in the blank. Right? You have a equals 1, b equals 2, c equals 5. All positives. How easy, right? Minus b plus or minus square root b squared minus 4ac all over 2a. Looks a lot like the last one, 2 and 5. But a little different result, right? Minus 2 plus or minus, I've got 4 minus 20 is square root of minus 16 all over 2. What is that? Again, we say the square root property applies to negatives, and we can write the square root of minus 16. Where this isn't a class in complex variables, but we still recognize we have this property, is the square root of minus 1 times 16. And we'll say, oh, that's the square root of minus 1 times the square root of 16 is I times 4. So this is minus 2 plus or minus 4i or I4 over 2. And we want to reduce this one too. So we factor a 2 out of the top and say 2 times minus 1 plus or minus 2i all over 2. Think of the bottom as 2 times 1. Then we can cancel a factor with a factor. And what we've got for solutions are minus 1 plus or minus 2i. I'll just write it in this short notation. The two solutions are these. So we got complex solutions, numbers with an imaginary I in it. And it tells you actually this one, if you factor it, would be the lead coefficient 1 times x minus the first of these, 1 plus 2i, times x minus the second of these, 1 minus 2i. That's how it factored if you wanted to factor it. What a mess, but it does factor, right? Every one of these factors. You just have to put x minus the first solution, x minus the second, all times the leading coefficient. So I didn't ask you to factor it because that's too hard, I thought, but here's the two solutions to the quadratic equation. Right? You do that in the final, I might ask these again in the final. I think these important concepts when you get out of class, if you can do these kind of things, you're pretty successful at calculus. But I've taught calculus enough time. What really kills people in calculus is two things. One, they come out of high school or some other school where they didn't ever have to do homework and they don't do their homework. That kills a lot of people. And the second one is they don't have algebra skills, and so they can't do the algebra. Once in a while, you get somebody who can't do trigonometry too, but usually if they do algebra, they can do trigonometry. So it's not being able to do these kinds of things or not being willing to study. The people who are good at both those things do well at calculus. People sometimes say calculus is hard, but this is because too many people go in unprepared to do homework and to know their algebra. But all this stuff, if you can do this, you can do calculus easily. So it's not harder than that. It's just new concepts and new equations. Okay. Anything else? I want to do number 8 because I think it's very important and a lot of people miss it. 8a says solve for x. Usually when I find students coming into later courses, when they're bad in their algebra skills, it's they don't remember logarithms and exponentials. And I think it's just uniform. Don't feel bad if you don't remember them very well because they're hard, I guess. So I wanted to review these for that reason. Suppose I solve this equation, log x equals 4.2. What is the value of x? Well, there's two ways to think of this. You can either say by definition, if y equals log x, then x equals 10 to the y. You could do that immediately, which works great, and I highly recommend that. That's probably a little faster than this. But I think the easier way to remember it is to do this. If you want to solve a logarithm equation, isolate the logarithm, it already is, and then take, if this is log base 10, then I'll take 10 to this side equals 10 to the other side. So if I take 10 to this side equals 10 to this side, then this equation, but 10 and log base 10 are inverses, they undo each other. 10 to the log base 10 of x is just x. Oh, x is 10 to the 4.2. And then you can calculate it with your calculator. It's 15,848.93. I asked for 2 decimal places accuracy, so there it is. Now, if you remember the definition of logarithm, it's even better. Y equals log x is equivalent to x equals 10 to the y. So you can go straight here if you want. A lot of people did. I just think that most people coming out have an easier time remembering, because this works for other problems. Just if it's log base 10, take 10 to the, isolate the logarithm, take 10 to the left equals 10 to the right, you can solve it immediately. So it's just one more step and easier to remember, I think. But that was that one. I want you to be able to do this. You know, if log x, if you have x in a logarithm, how do you solve it? You just isolate it and take, if it's base 10, 10 to each side. Now the second one is just like it, but base e. 8b is e to the x equals 5.3. How do I solve that for x? All right. This time x is in an exponent. If x is in an exponent, you isolate the exponent, the exponential on one side, it already is, and take the logarithm of the same base. So if I have log base e, if I have e to the x, I'll take log base e of each side to undo the exponential. So logarithm equation, isolate the log and take the exponential of the same base. Exponent, x and an exponent, isolate the exponential, take logarithm same base each side. So ln of e to the x undo each other, and you get x because it's log base e of e to the x. Oh, it's just ln of 5.3, and I run that on my calculator, and I get 1.67 to 2 decimals. Right? I really want you to be able to do those. I know these always come hard and they're the things people most have difficulty on coming out of. But if you can do those, you'll have an advantage. And you have to be able to do them eventually when you take advanced courses. Here's 10, just for fun. I think this is a similar problem, so I'm doing it at the same time. Y equals 2 times e to the minus t. And I say solve for t. This is what happens in later courses. So this is an illustration. How do I solve for t? If the variable's in an exponent I isolate the exponential and take logarithm of each side, right? So I'll rewrite this by dividing by 2, and y over 2 equals e to the t is isolated exponential. Then take logarithm of the same base of each side. Take ln of y over 2 equals ln of e to the minus t. And the logarithms base e and the exponential base e onto each other. And I've got minus t, the exponent, equals ln of y over 2. This time I made it a little harder than just e to the x. I put e to the minus t. So you got to multiply by minus 1. And get equivalently y equals minus the natural log. There it is. Right? That's how you solve equations with the variable you want an exponent. Isolate the exponential, take the logarithm of each side. And it works really great. You don't actually have to use the logarithm of the same base, but if you use the same base, it saves a step. So that's what I did. Anything else you want to see? I don't want to spend too long on this, but I want to make sure I hit all the important problems here. I know one more I want to do. A lot of people miss this problem. Again, it's logarithms, one of the harder parts of the course. This is number 6. Solve for x. Log base 2 of x minus log base 2 of x minus 2. You leave the parentheses off when it's just x equals 2 because people understand there's implied parentheses. It's a function. Well, I solve that. A lot of people dutifully wrote, oh, x times x minus 2 log equals 2 and got it wrong. What's wrong with that? Some of you got it right. What you have in your properties is log of m plus log of n is the log of the product, right? I remember all these. The log of the difference of two logarithms, log m minus log n, is what? Log m divided by n. So this one, since it's a subtraction, the left side isn't log of the product, it's log of the quotient. So I have log base 2 of x, the positive one, divided by x minus 2, the negative one. So that's how you combine the logarithms. And this is a major technique for solving when x is in logarithms. Combine all the logarithms, isolate the result, and then take the exponential of both sides to the same base. You can use any base, actually. Better to use the same base. So I'll say if these two are equal, then 2 to the left, just like the last problem here, equals 2 to the right. Right? There's an equivalent equation. Now 2 and log base 2 are inverse functions, so they undo each other. On the left is just x over x minus 2 equals on the right 2 squared is 4. What an easy equation to solve, right? Let's multiply both sides by x minus 2. And it's a linear equation, actually, right? When you multiply it out, this is x equals 4x minus 2. So I can subtract x over and add 2 over and get 2 equals 3x. And divide by 3. X must be 3 halves. That was number 6. I do want to make one point on this. Oh, wait a minute. I messed this up, didn't I? You know what? Got screwed up here. This was the answer, as I recall. I had done this one, I had written it up wrong because I just took log 2 for log 10. and I rewrote it in 0x thing and I count. So 0x the wrong copy. So this is a, replace what you see in your handout number 6 with this. And now there's one more thing here. Why is this wrong? What's wrong with that? There is an assumption that goes in here when you combine these logarithms that you don't get log of the negative here. What can happen is if, let's see. Let's see. I messed this up. Here we go. There it is. 4x minus 8. Sorry about that. No, wrong. So add 8 over an 8 equals 3x. X equals 8. There we go. So replace what you had on there with this. It needs that correction because I Xeroxed the wrong copy. Everything else was right. I had to fix that one. Log base 10. Okay. So I'll just have to fix that. But that should be 8/3. And then what you always do after you're done is you plug it back in and see that it works. Because of the following reason, I want to do one last problem on here. Be done with this. You guys look bored doing review. Or I just want to go home for Thanksgiving, probably. Be happy because I could be doing all new stuff for you to work on over your break, right? We are going to do a little new stuff, but all this is taking time away from doing something new to try and reinforce the old. Where'd that go? There, I'll just say it on this problem because I practice test or something. When you're all done, you have to check your answer by plugging in. Why do you have to do that? This was on the practice test, if nothing else. The reason is that when I combine logarithms, these actually aren't equivalent unless the top and bottom are both positive. Sometimes you get a solution where the top and bottom are both negative, and it satisfies this equation, but it doesn't satisfy this one because you can't take a logarithm of negative numbers. So these are equivalent provided x is greater than or equal to 0, so the top is positive, and x greater than 0, and x minus 2 is greater than 0, so the bottom is positive. If they're both positive, then it works. So you can just check that this makes x positive also, or you can check by plugging in, or that, or check x is greater than 0 is easier. So these are only equivalent if x is greater than 0, because when you combine these, you assume that their two arguments were positive. So that's the disclaimer. That was the problem on the practice test. When you combine them, you have to check this afterwards. So carry this all the way down, and then sure enough, x is greater than 0, so that one is a solution. All right, is that enough? I look tired of this, so. Also, maybe some of this, but still real difficult. Okay, yeah.
Can you do number 8 on 6.4?
Oh, out of the homework?
Yeah.
Okay. Yeah.
Sorry.
Yeah. No, that's good because we're doing 6.4 something today. Actually, let me get to that. If I forget for some reason, come back at me. But section 6.4 is solving or applied quadratic equations. parabola is the graph of a quadratic function. A quadratic equation is a quadratic function equals 0. So they're related, right? The parabola is the graph of the quadratic function. Quadratic equation is setting the quadratic function. All right. I will refer you to what I have over on the side here. I don't want to spend a lot of time on these because there's no new concepts in there. It's just doing some, seeing that these calculations to calculate the solutions of a quadratic equation and sketching parabolas and finding x and y intercepts actually are useful in applied problems. So we'll just do a few of these. And here's number 2. I'll start with number 2. We'll get to number 8. So actually, that was on my list to do, come to think of it. But Gilbert, it says somebody launches a toy water toy from the ground level. The height says the height of a toy. If you take physics, this is a very significant problem, by the way. Above ground level. At time t, seconds. Suppose it is h, they wrote t, equals 128 t minus 16 t squared. When will the rocket reach its greatest height? But this is a very important problem because they ask you this in first year physics, always. What time is the greatest height? Here's why this is significant, actually. This is a real equation for objects that are not affected by air resistance. A toy probably is, but in this problem. But if you have a rock or something, it's pretty close to this trajectory because the acceleration of Earth's gravity on an object near the surface of the Earth is nearly exactly 32 feet per second squared, we say. That's the acceleration, is units of distance per time squared, calculus concept. But it's 32 is the point, downward. And so if height is upward, then the acceleration is minus 32. This actually turns out to be acceleration divided by 2. You have to take calculus to see. And then this is its initial velocity. If you fire a rocket heavy up at 128 feet per second in Earth's gravity, 32 feet per second squared, any object you fire, heavy object you fire whatsoever, ignoring air resistance, follows exactly this trajectory, and it's a parabola. When you fire an object up from ground, ignoring air resistance, it makes a nice parabolic trajectory. Parabolas are extremely important in trajectories. They use this to figure out where cannonballs will land and that kind of thing, right? So this equation is, odd as it seems, is actually very significant. This comes from the gravity term. This comes from initial velocity. And if he fires it not from ground, you can add a number to this from initial height. But so we don't need to know any of the significance of those. I just wanted to point out that these numbers actually are quite significant. This is his initial velocity. This is his acceleration in Earth's gravity, and you learn that in first year of physics, not here. When is its greatest height just given this equation in physics? They ask you that, right? How high does the rocket go if you fire it at 128 feet per second upwards? How do I find the highest height? The thing to do is to recognize this is a parabola, right? If you call this h of t, is a parabola. Or let's call it, let's call it h. Say it's the y coordinate, and we have a downward parabola because the coefficient of t squared is negative. So it's downward when you have a negative number times t squared, because that turns the parabola upside down. And it looks like this. The trajectory looks like this. It starts at t equals 0, and h is here, and it makes a downward parabola. And the idea is that one solution is at ground level when t equals 0, right? Because you plug t equals 0, get 0 plus 0, h is 0. So it starts at ground level in this problem. But where does it reach ground level again? How about that? You can solve this. What you're asking is, when is h equals 0? That's what the question is. H is the height above ground. So when is h equals 0 is the real question. You first translate it and you say, oh, it's just 0 equals 128t minus 16t squared. And what is it? It's a quadratic equation. Every cannonball follows a quadratic equation to find its trajectory. Right? Quadratic, and to find its impact time, I guess I should say. Quadratic equation to find the impact of the cannonball or Dilbert's toy. How do I solve a quadratic equation? Yeah, either factoring or the quadratic form. I would say here factoring is easier. Right? 16 goes into both these numbers. I could say this is 16t times, let's see, 8, right? Times 8 minus t equals 0 is this factor. And now the solutions are obvious, right? T equals 0, that's when he's initially firing it. Or t equals 8. It reaches its maximum height at t equals 8. This is when he initially fired it. Isn't that picture beautiful? I mean, that really helps you understand it. When you see the problem written like that, you don't get this beautiful concept here, the parabola, but it's really nice. And that's what this section is trying to show you. Is parabolas are real useful. I already told you about all those things with flashlights, right? The flashlight, and the reason it makes a beam is if you have a parabolic or roughly parabolic back, all the light rays coming off the bulb that's shooting out in parallel rays. It's an optical property of the parabola. That's how you make a beam. Or if you have a radio antenna, it has to be parabola to focus radiation to a point. All right, radio waves to a point in that case. But there's part A. Part B, I don't wander too long on this stuff. We can never do all the problems. That's the trouble here. So you have to do some at home and bring me questions. I think you'll learn more if you ask questions than if I just lecture all the time without questions. Find the maximum value, find the maximum height. How do I find maximum height? That's the time of maximum height. HT for height. You just plug it in. Right now, H is 128 times 8 minus 16 times 8 squared. Just plug it in. Now, what do we get? This should be 1,024. How did I know that? Sometimes it looks like math magic, right? These are powers of 2. This is actually together. This is 2 to the 7th, and this is 2 to the 3rd. It's 2 to the 10th, and I've memorized that 2 to the 10th is 1,024. That's very important in computer science, right? Because this is a kilobyte is 1,024 bytes, 2 to the 10th bytes. But see, I recognize 2 to the 10th. That's how I get that. It's not all that magic. And then this one, this is 2 to the 4th times 2 cubed squared is, let's see, right? So this is 2 to the 6th, and this is 2 to the 4th. I'm sorry, I didn't get maximum height here. I'm going to get the impact. I'm going to get impact at 0. My apologies. I'm finding, and I'll get 0. 1,024 minus 1,024 is 0. I put in the greatest height time, and sure enough, I found the height was 0. Sorry about that. Find the maximum height. Here's where the vertex comes in. So sorry about that. The maximum height occurs when you solve quadratic function equals 0, finding the x-intercept, or t-intercept in this case. But now the vertex comes in here. The maximum height is at the vertex, right? Right here. Where's the vertex? Actually, a physicist gets doing enough of these that they start to get some side tricks. Can you guess where this, if this is t equals 8, and this is t equals 0, where's it at maximum height? 4, halfway in between, just by symmetry. A physicist knows a parabola is symmetric. It has this axis of symmetry, we call it. And just put, oh, the impact time is 4, so you can guess this one. But I want to emphasize that even if you hadn't already calculated this, you can calculate the vertex. What's the vertex of any parabola? AT squared plus BT plus C is? Remember we memorized it for last time? Probably not, because it wasn't on your test. But last time we said the vertex is always minus B over 2A. You memorize that because we did it by translating and so forth. You see this again in calculus, so it's really useful to know this. But they'll prove it again in calculus, so if you don't, it doesn't matter. But it's minus B over 2A always. This is the formula you get by stretching and shifting any parabola to that standard form. So it's let's see if I write this as minus 16t squared plus 128t plus 0, then this is A, and this is B, and this is C. So it's minus 128 over 2 times negative 16 minus a cancel fortunately, so I don't get a negative time. And so I get 32 on the bottom, goes into 128 4 times. So this is 4. Sure enough, there it is. It's halfway in between. So we find t equals 4 is the time of maximum height. And then the maximum height is by plugging in. H equals 128 times t equals 4 minus 16 times t equals 4 squared. Now I'll get an interesting result. This is 2 to the 9th. It's 512. If you remember all your powers of 2. All right, 2, 4, 8, 16, 32, up to 1,024. 512 is 2 to the 9th. And then this one is, let's say, 16 times 16 is 256. And so you get the maximum height is actually 256. And it's feet because height was measured in feet, actually. So it goes to a maximum height of 256 feet. It reaches there 4 seconds into the trajectory. And now you can see how SpaceX and all those people, when they put the boosters up there, if it's not too affected by air resistance, you can figure out exactly where it's going around to. Now, in truth, those things are affected by air resistance, and they have to do complicated things to get the accurate results that they need. But still, if it's heavy enough and not too aerodynamically inclined, then we can get a pretty accurate result. All right. So we're all physics majors now. A lot of you are not physics majors, but you can still see that the intercepts and the vertex are very important things in applied problems. That's the idea of this section. And you just do the same calculations as before, just for applications. Let's look at number 8 then. The page didn't bring it.
It's that one.
This one, yeah, right, well, yeah. Okay, so let's go over to the next one on the screen. Put it online. There's the whole thing here doing that. Too many buttons here. It's easy to push something wrong and never get it back, unfortunately. All right. So Lightwell Incorporated makes fountain pens, and it costs Lightwell. This is a cost analysis. Maybe some of you are business majors now instead of physics. This is a common thing to get parabolas in cost analysis too. And cost and price. Like if you make a price, golly, I knew it. Let's try it again. See if that brings it back. Oh, it's got left and right backwards too. Technicians don't know their right and left hands apart, I guess. All right, so there, now I've got it. Rightwell makes fountain pens. It costs Rightwell this many dollars. It's parabolic, and sometimes this works this way because it might be that it costs you. Well, let's do this part. And if this is the cost when you make X units, right, of the product, X pens in this case. And now suppose your revenue is the money in and cost is the money out. And so what do you think is your profit then? If this is how much money you get in the revenue and this is how much money you go out the cost. You take revenue minus cost, the dollars in minus the dollars out to get the profit. And so if I want to do a cost analysis of this thing, I'll say, what's the break-even point where I make enough units that my profit is 0 at least. I don't lose money, right? Well, that's when revenue equals cost, or profit revenue minus cost is 0. So you write that down. They said write a system of equations. By solving a system of equations, you don't need a system. They wrote that in the book. But we can do this with parabolas here, which is the point of the section. Let me move this back. All right. So here's the example. For a company, cost is C, a function of X, equals 0.0075 X squared plus X plus 2,100. Revenue, money in, is R. If you see your beginning business mathematics books, they use these same letters. We do business calculus here as one of the courses, and we'll use these R, C of X and R of X, these functions in there. Here's 13X dollars, and this is dollars also. Find the break-even point. That's the first time you get enough units so that haven't got negative profit, right? You're not taking a loss. Find the break-even point. Let's just say it that way. It's revenue equals cost. Money in equals money out. Well, then you put 0.0075 X squared plus X plus 2,100 equals 13X. And this is what they're referring to as find the intersection. What you're thinking of is this is a parabola, the cost, right? And this is a line here, Y or R equals 13X is a line. And the break-even point is where they're equal, where they intersect. So this one, it looks like the x-intercept, if you find that the y-intercept is 2,100, right? If you put x equals 0 in here, you get C, or y if you like, put y equals dollars, and this is x, the number of units made. And so if y is the cost, if I plot y equals the cost, then I get, when x equals 0, I get 2,100. And now the cost is going up because its coefficient is positive, so it's a parabola upwards, and it goes something like this. Oops. All right, so it's an arch shape upwards. You can make it down something like this if you do the whole parabola. All right, but we want this part of the parabola because we're only interested in positive number of units that we're producing. We can't produce negative units, so we draw part of the parabola. And then the revenue is 13X. This is a line through the origin, right? If you put Y equals 13X, what is this? How do you sketch that? Remember lines? Think of it as Y equals 13X plus 0. It's Y equals MX plus B with slope M equals 13 and Y-intercept B equals 0. So it's a slope 13 goes up like this and intersects the parabola. And so this is Y equals 13X. The revenue, this is Y equals 0.0075 X squared plus X plus 2,100. The cost parabola, and this is the break-even point where revenue equals cost. And if you go a little bigger than it, you start making a profit until these intersect again over here. And if you make too many, your cost becomes prohibitive. And you start losing money again. So there's a range in which you can make money. You have to make a certain number of units to break even. If you make too many, it's costs you too much money and you lose money. So there's a price analysis. Where's the break-even point? It's right here by setting these two equal where they intersect, right? Intersection. Or you can write the whole thing, subtract this over, and write a parabola and find the intercepts instead. That's what I was going to do originally. So this is the intersection of these 2 points. Now, how do you solve that? You just use the quadratic formula, right? It's a quadratic equation, so you have to get 0.0075 x squared. I subtract 13x from each side and get minus 12x plus 2,100 equals 0. Once I get 0 on the right side, I can either use factoring or the quadratic formula. Well, with these little tiny numbers and big numbers, there's maybe a lot of ways to factor it. So let's not use factoring. Let's say that x equals minus b is 12 plus or minus square root B squared minus 4 times A 0.0075 times C 2100 all over 2A. It might be easier to multiply this through, or divide this through by 0.0075. I don't know. But this will work. And we'll get two answers. Which one do I want? What happens, I mentioned to you before, if you keep taking this up, I'll go out further. The parabola eventually intersects the line up here and you start losing money. Vertical, there's not a function. And so what you want is the smaller of the two. So you want the negative side. Smaller intersection is the break-even point. All right, I'll let you run that on the calculator. But that's how you figure out the break-even. That's the hard problem, I think, at the end. I just put a nasty one right at the end just to frustrate you when you just thought you were done, I guess. Now, here's the next part. Find the value of X for which the profit is maximum. That's what every business is interested in, right? How do you maximize your profits? You pay your employees a lot and build new factories and so forth. B, how many units or what value of X provides maximum profit? All right. Well, profit is defined to be, I'll put DEF for definition, revenue minus cost. All right. So the profit function is what we wrote here. It's 0.0075 x squared minus 12x plus 2,100. The revenue function minus the cost function. That's the profit. Now, how do I find the maximum profit? Oops, I wrote this backwards though, didn't I? It's backwards. Revenue minus cost gives minus this one, plus this one, and minus this one. There's revenue minus cost. So it's just minus this function. So how do I find the maximum? We got a clue. What you recognize is that this is a parabola, right? It's a downward parabola because the coefficient of x squared is negative. It's downward parabola. So where's the maximum of a downward parabola? So this vertex, right? So here's the applied problem again. T, or x in this case, is minus b over 2a, right? So I just take A, B, and C, and the maximum profit is where at minus 12 over 2 times minus 0.0075. Let's run this one and see where it is. So the minuses cancel. Let's not even put those in. 12 over 2 is 6, so I'll just take 6 divided by 0.0075. Hopefully I get that right. It's 800 units, 800 pens, I guess it is. So the company will maximize its profit if it makes precisely 800 pens according to this cost analysis that they did. There it is, some applications of parabolas. I hope that helps you to do well on 6.4. Yeah.
What was the point we were supposed to put in for the answer to the first one? Like, I got the x values I got were 1400 and 200.
You know, they have the answer up here. Put it out. Let's see. let's look back on this and I'll. Look at this. Here's Ed Kennedy's answers. They give me the answers. Here's the quadratic equation we wrote, or the intersection we wrote. This parabola and this line. Here they are plotted nicely in the computer. Here was the lower solution. Apparently, it's x equals 200, and the higher one is x equals
1400.
1400. And so this is the break-even point is x equals 200. I think they just wanted you to put 200, didn't they? That's what I was looking for as the answer on here. Let's- gives the answer on these two. Let's see what the question said again. Find the break-even point. We can try it. I think they just want x equals 200, but maybe they want the x and y point.
Yeah, they want a point.
Oh, Renee, let's see. Your second coordinate should be revenue divided by cost value. So what they want in here is 200, the value of x that makes you break even. That's the number of units. And then you want to put in y. Your second coordinate is supposed to be the revenue divided by the cost. You got to plug in 200 for the revenue. Revenue is 13x, so it's 13 times 200 is 2,600. So, I'll take revenue divided by cost. 2,600. And the cost is this one plug in 200. 0.0075, 200 squared, plus 200, plus 2,100. Comes out to be 2,600. So revenue and cost, you get one. And this guy the break. So apparently they want you to put one for the second coordinate. 201 is a. See if it likes that.
Did not work.
Yeah, it says your second coordinate for your break-even point should be, let's see. Oh, it's 200, 2,600. The idea is that this point right here is the break-even point. X equals 200. And Y equals Y, the revenue, the cost. So it should be 200, 2,600 is the solution. People online can't see this. I guess I should move it.
That did not work.
That one should work. No?
There's 2 points.
There's 2 points.
But can you plug in 13, 1400, 13, 200? You get 2 points.
Oh, they want you to put 2 points in? Okay. Break even points. Do you want to put in 200, 2,600 twice, you're saying?
It's like 13 and then you plug.
Oh, I think. Wait a minute.
Why?
But 200 is the X.
Yeah. I got the answer.
See what I did?
Well, they're asking you to put in this trouble with computers. Is they-
It's that's not what I got. I got 200 and then 2,600, and then the other one was 1,400 and 18,200.
Okay. By putting,
You just plug them into the 13x.
okay, so put both, they put the break even and the second point in.
Yeah.
Okay, so this is where you first break even, and this is where you start to lose money. So this is what they want. All right, well, I hope to get further today, but at least we got through that section. We'll have a nice vacation, and I'll move 7.1 to you later. But this material in 6.4, please do it on high. Here, everybody have a nice break put in. That's nice.
Have a good Thanksgiving.
All right.
Have a good break.